Webinar. We have Cory Sorice with us. He's going to be speaking to us from Masonite. He's the Chief Innovation Officer of Masonite, a leading provider of residential and architectural door systems. He's recently pioneered the launch of an integrated powered and connected exterior door system, partnering with Ring and video doorbells. So the smart home is here. The smart home is now. And this is certainly a big chunk of it from the homeowner's perspective. I just want to emphasize the importance of innovation to the curriculum of MEM and to the basic foundations of MEM. It was founded more than 45 years ago. And the whole point of it was basically to bring innovation to business and management training. We felt, and we still feel this way, that there's not enough innovation focus in traditional MBA programs. And we feel that the MEM fills that gap and really focuses on building and establishing the innovation-driven enterprise. So I'm sure Cory will have a lot to say about this, and he's got much more to say in the future, but let's welcome Cory for tonight and hear what he has to say about business model innovations.
Hey, everybody. How you guys doing? Cory Sorice, the Chief Innovation Officer at Masonite. And, I had a chance to talk Mandy and Mark about the idea of talking about IoT systems. I've actually spent quite a bit of time in both product development, innovation, as well as IoT systems and related business models. So, I thought I'd offer just a quick background, kind of a resume on a slide, mostly logos. I had a chance to do a startup in the web services arena around patented technology. Worked in primarily, other than that, retail and consumer durables, companies like Black & Decker, New Rubbermaid, Chamberlain and Garage Door Openers before joining Masonite, which has really been fascinating, being the Chief Innovation Officer of doors, residential and exterior and interior doors, as well as commercial architectural doors, what we call them. And we've recently announced and launched a powered and connected door system. We announced it with a lot of fanfare at the Consumer Electronics Show this year. It got really positive press about beautifully integrating smart home products into a residential exterior door system. In fact, exterior doors have had innovation all around them. And what I'll talk about a bit today is this idea of what that looks like as it starts to come in. When we think about the Internet of Things or IoT, it's actually a fascinating journey to think about the way ecosystems are evolving. Because traditional manufacturing is about component providers creating components. There's typically manufacturers and assemblers that design engineer things for specific use cases. That could be a drill, it could be, a loaf of bread. And then, there's typically some kind of retail function that takes you to channel. What we want to talk about today is really how that's shifted, especially with emerging and evolving technologies. So then we'll talk about and turn it over to the components of an Internet of Things system. And over the last 15 years, I've spent quite a bit of time designing systems, leading teams that have implemented systems, and then sharing those systems with other network connected devices. The thing about it is, actually, as we move away from the technology and into what it looks like to design the system, we want to think about that, especially in a master's program. You're not just thinking about the technology implementation or even just the innovation. You need to think about the business model of this. We'll talk about what that looks like in terms of providing a piece of hardware that then also delivers a service with it. What does that mean? For most of us, that means we have an expectation that starts to exceed that of just the device failing its hardware. You have an expectation for an app, for cloud services, connection maybe to an Alexa device or to your car. Those services are an obligation for a company as the system gets designed, and it costs money, real money. So we'll talk about that in terms of what it looks like to have a lifetime relationship with a customer, the pluses of it and the minuses. And then we'll talk about business model approach. Actually, what's really fascinating as you move away from just selling a thing once and then having an interactive relationship There's a few different ways to do that. I'll talk about the philosophy of it first, and then we'll talk about an example just to kind of shake things up on different ways to go at it. So with that, one of the things that I talked about is this simple, kind of value chain of old, which is a 3-step model. I mean, some can be 4 or 5, but the reality is, you can go get a whole handful of components. If you think about it from an IoT standpoint, a vacuum cleaner is an example. There are companies that are multi-billion-dollar companies making nothing but fractional horsepower motors. And from that standpoint, they're defined. There's a low-cost global supply chain in the world. Automotive manufacturers buy, 20 to 50 of them per car. Heck, Tesla makes even really big ones now. That linear process of a relationship also has with it clear lines of demarcation of how the different players play. And, a manufacturer can decide to go upstream and make components if they're proprietary and special. They can go downstream and talk to customers and channels in a whole bunch of different ways now. For the most part, you see, a Home Depot is a Home Depot, and a Black & Decker is a Black & Decker, and a fractional horsepower manufacturer like Johnson Motor makes motors. And those were, simple times. And, one of the things that happened as I spent time in my last company, Chamberlain's, we started to realize things were shifting. The number of players, the number of technologies, and the number of interested parties was shifting dramatically. And now players that you had never anticipated being important players couldn't come out of the woodwork and actually become competitors, or could be frenemies. They could, do this thing. We would always talk about co-opetition. They could sell you parts. They could also compete with you. And in that marketplace, and that environment, thinking about the ecosystem of all the players is much more complex. What does a competitor look like in your world? If we think about mattresses, if you're Sealy and you sell to retail distribution, the local, kind of small shop distributor, a Casper coming out of the woodwork, all of a sudden is an opportunity to threat. Casper doesn't make mattresses. Casper supplies from a whole bunch of different players. Casper sells direct to homeowners. It doesn't have a retail footprint, so its cost structure is totally different. And they priced it that way. So, you start to look at the channels as well as the technologies. What starts to come out of this is there are players that become new and different players in the space. And in an analysis we did in the connected home, there are hundreds of these players. So it's always interesting. I get into these conversations on panels or professional recommendations within a company, and people will say this. Many of you may say this. I can't wait for there to be one app to connect my home, to control my home. Now, what's interesting about it, Stacey Higginbotham, who writes a great publication, Stacey on IoT, talks about the fact that she doesn't have a single brand home. In fact, I'm not sure we'll ever see a single brand home. If you look on here, there are dozens and dozens, if not hundreds of brands in a home. And part of what that means is, as we look at a more complex world, there are a lot more opportunities to create value, a lot of opportunities in ecosystems to work with other parties to create value, and expectations of homeowners. As you look up and down the channels, as well as vertically, you start to see that different players, much like in the first slide I showed, start to demonstrate that they have a lane. Lanes look different though. A player like ADT, that is in the lane of, kind of security, has a lot of new players to think about. About 7-8 years ago, Comcast decided to become a competitor of ADT because it had trucks. It could work on its workforce, and that workforce could then also go to someone's home and help protect people in their daily lives. Well, ADT, as you can see, not only were they an ecosystem platform, they decided, what we can do, we can get into services and provide healthcare benefits for people who are aging in place. It's a fascinating way to think about where the marketplace is going based on leveraging your strengths, and also highlights the fact that you can have competitive parties you would never anticipate before. these things start to create kind of strengths, weaknesses, opportunities, and threats, like classic analysis from a strategic standpoint. But in a chart like this, you start to realize that those verticals, who would you partner with, where do you see yourself as a manufacturer, and how would you participate in the space, creates a lot of new adjacencies as you start to think about what an ecosystem looks like. What's really interesting in IoT, 20 years ago, I worked at a company that wanted to get into connected lighting systems. 20 years ago, there was no smartphone. There was not even the beginning of BlackBerry. And at the time, actually, homeowners said, I don't want another control device in my home. I don't want another remote. And it was interesting. This idea of having another remote in your home was actually more complex than the benefits of the features that you got from having a connected light. In 2007, when smartphones came out, they started talking about having a multitude of features on a smartphone. It was really interesting, and this kind of consolidated into what Apple and Google did with Android. They started to put together a set of features that became very powerful and be hard to replicate. And in fact, even Microsoft tried to step into this arena and had a hard time doing it. If you think about the operating systems for a smartphone, and you look at 4 main quadrants for those smartphones, they compete in very critical areas. They compete with navigation and maps, really where your location is. They compete in your car, kind of how you get from place to place. They compete with controls that aren't the phone, like voice controls. And notably, they've started to get into home control. And what's important about that is that all sits on top of their operating system, and they control their operating system, which means they control the use cases of the things that go on top of their operating system: location, car, home, voice control. They become really important players in the value chain. When you're designing a system, you have to think about how Apple and Google are thinking about your marketplace, your use cases. They offer an awesome benefit in that you can put software on their phones easily, that they approve, of course, that allows you to interact with devices. They also can decide, like I showed you in the last slide, to get into your space. A really great example of that will come up when we talk about location services. It's a really cool company that made location tagging, and Apple decided, we're going to do location tagging. And all of a sudden, a player with a piece of hardware and an app has a new competitor that happens to be $1 trillion company. It makes it very difficult to survive in that space. So one of the things when we think about transitioning from an ecosystem to thinking about designing a system yourself is really about the use cases, kind of the way you would approach designing a system and some of the standards of that. Before that, I'm going to pause. So I talk really fast, and I thought I'd give you all a chance to ask any questions. If we think about ecosystems, is there anything that you guys have as questions around ecosystems? No.
I do have a question.
Okay.
Could you define the difference between an ecosystem and a platform?
It's a great question. So typically, at least the way I think about it, platforms are typically ways for a series of players in a standardized way to operate on top of a company's offering. A really great example in the early days was the way Nest operated with Works with Nest, which had specific parameters around how you could work with the thermostats back in that day, what data you could get, what data controls you could have. And there was an authorization level that moved companies from participating with the platform in a beta format all the way through to production. And they did that across hundreds. Actually, I think the number got to 1,500 companies that were in the beta program, and a few dozen that actually launched in production. Ecosystems, as I showed earlier, have a much broader set of competitive boundaries to it, and can involve a number of different business model approaches, as well as players and constituents as you go from core components or services all the way through to a delivered product or service to an end user or consumer. And in that way, you can have a number of different platforms within an ecosystem. You can have a number of different business model approaches that can happen, anywhere from charging for a service to charging for a piece of hardware. And notably in that situation, if you think about it, Apple is really excellent at hardware and charges quite a premium for it. And for the most part, you see an Amazon owning commerce and a Google owning search and paid search. So those all participate in an ecosystem, which is around internet technologies, but notably they have very different business model approaches. Does that make sense?
Yeah, absolutely. Thank you.
Yeah, that's great. Thank you.
So Cory,
Yeah.
I guess one of my questions is I've been watching this smart home space for some time. It seems like within the US, there's been relatively little penetration of any one given ecosystem or platform. It's been more than 5 years. I want to say closer to 10, right?
Yeah.
So in those 10 years, I guess why haven't we seen more penetration?
Oh, that's a great question. In the early days, we launched at Chamberlain a connected garage door opener called MyQ in 2011, August 2011. One of the first limiters was smartphone adoption. So at that time, smartphone adoption was around 30%. And we had grandiose dreams that we were going to be able to get to very large adoption levels for our garage door openers. But when the rate limiter in population is 30%, some level underneath that's going to be interested in it, which at the time for us was 10%. So 3% of the market was interested. And then you had to own a garage door opener and you had to register your garage door opener. Now what we've seen is the adoption of smartphones to move to effectively, I won't say all smartphones, but all phones are smartphones that are cell phones, because you still see burner phones, et cetera. You see a high percentage now, north of 80% of phones that people own are smartphones. And you see a high percentage of people in population that have smartphones. And the analogy I gave earlier about having a control device, IoT systems work best with a smartphone, better than a computer or a laptop, et cetera. So that prerequisite over the last 10 years has gotten up into the 80s. Home networks has gotten up into the 80s. It's kind of been 75 to 80%, depending on people who choose over the top services and unplug. So then you have the foundation of then use cases. Now you start to get what's interesting, like what are the application cases that are simple, affordable, and kind of bubble to the top. In the smart home, your front door lock, your entry lock is kind of around number one. Number two has been your thermostat with Nest and Honeywell now. What's really interesting as a segment is professionally monitored security systems, which again is limited by the number of systems deployed. New systems deployed are about 50%. So what we're seeing now is a convergence of different categories. Areas like video doorbells as well are starting to get the total home, connected home penetration in the, I would say closer to 30% of homes, but you have to want it. So I think, Mark, the last part of that is, if you're interested in connecting to your phone, that's great, but there's actually still a pretty big percentage of people who are laggards, technology laggards, that don't trust the internet. And if that group of people is around 20%, which is probably not that far off of reality, it'll be a long time until we see numbers go over 50% of the total population. So it's a fascinating space to watch emerge. I think the last part of it is, I think everyone's waiting for an answer to come on convergence of technologies between all the major platforms. The rumor is Matter, which is an agreement between Nest and Google, Ring and Amazon, as well as Apple, is becoming an emergent standard that has been published over the last year. We'll start to deploy in the next 6 months. People have hopes that will be a communication protocol that will enable disparate systems to connect to each other better. But that still needs to adopt. So complicated answer to an easy question.
Maybe the lack of a standard is perhaps the single standard, right, is the single biggest issue blocking adoption. When I was in this cell phone business, when digital came out, there were lots of standards. GSM was adopted by the Europeans as the standard for Europe, and that became the de facto standard for the world. So once that happened, adoption quickly sped up. So
it's interesting, you know, having seen a lot of the players, what happened was Apple HomeKit thread from Nest, and the way Amazon was thinking about its voice control with the way it was using Bluetooth in conjunction with its hub. All the players all kind of came in and said, "Hey, we haven't figured it out yet. Let's pool the resources." And my early opinion was it was a bit of a discount bin. But to your point, I think you're right. I think what's happening in the marketplace is people are, you know, you don't want to spend $100 to $2,000 on a device and not be sure whether it's going to actually work in the future. So I think that's right.
Everyone wants future proofing. So
yeah, it's tough. It's tough. And you know, the thing I learned in IoT early on, if you don't have a valuable single use case, having an ecosystem doesn't really matter. So, you know, what we are delivering with Masonite with an M-Power powered and connected door is we're bringing your home's power to devices in your front door, your video doorbell, your lock, and LED lighting. If you don't value that as a floor offering, the reality is the stuff on top of it, delivery services or, you know, automated access control, those things, you know, those are harder to get people's head around, especially when they involve a number of different parties. So it's a great question.
Okay, thank you.
Well, thank you. All right. So we're going to dig into IoT components. What's fascinating here is, you know, typically, and it's interesting, Lyndon Tibbetts, the founder of IFTTT, talked about this idea that anything could have a sensor on it, and anything can provide you data about its state, about its activity, the interaction with the world. And that data could actually be then connected to a network, and that network could then collect information that could then have actions as well as provide information for the future. So in this simple framework, what we see is then taking a device that you have around you. It could be a dishwasher, it could be your car, heck, it could be a wheel on a car, it could be the tire on the wheel on a car. It could be a lot of discrete items that could be censored, that could have a state and can be controlled. And what's interesting is it's fascinating to think about what sensors you would deploy, what are the different states of a device, and then what control functions can occur in the device and outside of the device. And then what does the use case look like when you extend from the device to the cloud, and then manual and automated intervention, as well as, and we found from a product development standpoint that's fascinating, is quantitatively knowing how people use things. And the information that comes off of now not doing research to ask people how they use something, but quantitatively knowing from the device directly how things are used. At Chamberlain and garage door openers, there was always a theory about how many times people open and close their garage door every day. And then we deployed the first 50,000 units. And it was the first time the company quantitatively and with high assurance knew what that number was. And it was about 5 to 6 times a day, people were coming and going from their homes and opening and closing their garage door, which was kind of close to some people's kind of predictions. And it was kind of far away from others. And if you think about it, if you're the head of engineering in a garage door opener company, and someone says, some product person, some business person, some marketing person, I think people come and go from their homes 2 times a day. and you design a product to that with a defined life. And then you engineer the product to have a warranty. And then you make promises in the marketplace. You have a very different premonition than if you said, I think someone comes and goes from their home 12 times a day. And in fact, once you start to understand how people use their garage door functionally, especially from a reporting standpoint, you get a whole bunch more data about how you would value engineer a product. In fact, that data is so intimate to the company's knowledge about how they would develop the next product that you really want to be very careful about how much you would share that outside of your enterprise. It's very strategic data. So having a sensor on how your data works gives you a tool on understanding how people use your product while not actually sitting in front of them or asking them about it. Having a cloud connected platform or a connectivity approach that provides the way to have the telemetry to that device in an interactive way, in a two-way function, creates the capability to do that. And then having rules engines and how those rules engines interact with that connectivity function start to give you the ability to start to think about what actions you would take as a result of that. So if we start to think about the way the model operates, then you can think about different devices in your home and what you'd want to know. You can say, I have a washing machine. Now, if I have a washing machine, what kinds of sensors would I put in a washing machine? Right? If you think through that, what do you do with a washing machine? You put different kinds of clothing in it, different weights, different densities, different levels of dirt, filtration for the water, the way the airflow and the air quality goes in there, the detergent, the fabric softener, the temperature. In fact, you can probably name off 10 to 20 different things you would want to sense in the operating kind of parameters of the device. So you may not, with a washing machine, want to control the time at which it operates, but you may want to control water hardness, how much detergent's delivered, what kind of scents delivered into there, what kind of wash cycle it is, how you're actually spinning the clothing and controlling the clothing. Once you go to electronic controls as controlled on a dashboard away from the device, you actually start to open up operating parameters that are much more sophisticated. You have to be careful not to offer those parameters in a way that are very complex for a user to understand. But I think that's exactly what Tesla did when they censored and they looked at controls and they started to take electronic motors and they looked at acceleration as an example. They could look at exactly when a wheel would slip, and they can manage a power torque curve repeatably to get really high acceleration by censoring a wheel and controlling a wheel, right? And being able to discretely map that out and the amount of data back over and over and over again. In fact, Bosch has said they collect billions of data points off of their brakes that are now deployed into cars. Super interesting how they collect it. You get a car with Sirius XM and you get your free trial. You're also authorizing, guess what? A sensor in your car to a connectivity platform, right? Via the satellites and cell phones to then collect the reporting data about your car. So in fact, there's a really interesting business model approach that's been taken by automotive manufacturers, Sirius XM, and then a whole bunch of the players in the ecosystem for car manufacturing that have come together to provide diagnostics and reporting data in ways that now a whole bunch of manufacturers get access to that information to be able to make their products more reliable and to understand usage. So we're gonna double click from here. Before we do that, any questions about the framework? If you think about the products that you've worked with, the way you've approached designing systems, any questions on this? It's pretty simple 4 buckets, but if you start to play with it within your own experiences, any questions or thoughts there?
I have one question, but it's more about the door and how you manage to connect different devices from different manufacturers to the same platform. For instance, Yale supports Zigbee, Z-Wave, Ring is able to connect to Alexa. What is like the foundation systems that use your door and like aligns it all together?
It's kind of the one app question. It's a great question. You know, what's interesting is, as a strategy, we're offering something that hasn't been provided before, which is power. So we have not offered a unified application experience. And in fact, working with Ring via its Ring alarm, we'll start to have a kind of a single app approach with Ring. And I've provided information. We'll do the similar things with professional monitored security systems like an ADT or an alarm.com, as well as with a Google and Nest. So that's at the application layer from an internet control standpoint. And a Yale actually has a multi-radio approach on how they design incorporating their radio protocol. So they have about 14 different radios and radio modules that are slottable in their lock, and you can actually move from having their Bluetooth connectivity radio to a Z-Wave to a Zigbee, and it's the same hardware chassis, which is a fascinating design in a kind of multi-protocol arena where each protocol requires different radio frequencies and different communication standards. Once you get into video doorbells, it's different. Video doorbells from a video processing standpoint then work primarily through Wi-Fi on a home network, directly connected to a connected platform for data transmission to an application. So the video lane for most players is direct between the hardware and the application. And they effectively use port forwarding techniques, very thin clouds, and own all of their own video transmission because of the nature of the way that communicates. So you'll see a Ring on its video doorbell communicate almost exclusively to its own app with no sharing. You'll see a Yale communicate with a whole bunch of different hubs with different radio techniques for lock, state, and control. And what we do is then we go to both of them, and our little twist is we offer a power management system that's connected to your home's power on one side. It's brought from 120 volt high voltage to low voltage, carried from the frame through to a door slab. And then we're providing a replaceable system for those components with IP protected connectors. So what we'll have is a power platform that we will work with a series of players on, that platform will then allow those players in conjunction with us to offer accessories like video doorbells and locks, et cetera, that will be connected to that power system. So our business model approach, right, interestingly, is not about the connectivity piece because Amazon, Apple, and Google are out there already. Ours is about the power piece and how we deliver power to it. Does that make sense?
Yes, extremely. Thanks a lot. But I have a small follow-up question.
Mm-hmm.
Power is amazing. I got that part of business model. But what about the second part of the business model, distribution? Like when I use your power, I become stick to your power system, to your door technically, yeah? So your company becomes a seller for my product. How is that part works?
Yeah, that's it's a very good question. That's part of the approach is moving Masonite from being a components provider. And we've talked about this. Actually, we have a really interesting presentation in our investor relations section where we talk about selling components to selling systems. I personally look at what the automotive manufacturing industry has become. It's become an integrator of technologies, right? And when you go buy an Audi or a BMW or even a Chevrolet, it's very hard to just go out and get whatever you want and put it on that car. The cars are ever more becoming integrated systems with integrated connectors at the physical layer and then software systems that authorize those devices on the firmware and software side. So no different than computers. Like there's a lot of industries that have leveled up that part of the authorization model. And we work closely with video doorbell players and lock players and say, we sell as a company 34 million door slabs a year. We've got dozens and dozens of customers spread around the country. So you can work with us, sell a lot of doors. You can work with a whole bunch of distributors. And, our hope is that the preference will be to work with us as one player, as opposed to having to go and reach out into the market and deal with a whole bunch of different players. But absolutely the right question from a business model standpoint.
Thank you.
No, thank you. All right, so I'm going to double click. So if we take each one of these components in the design of the components, one of the things that's interesting is you can look at a state sensor, which is really about connecting the electronic, mechanical, electromechanical components of a device and using telemetry from the device, having enough firmware and processing power and memory to be able to get out. There are actually a growing number of options on the IoT platform side to get started. In fact, with Masonite, we're using Google IoT. My last company used IBM IoT services, but most major players have evolved, and I'll talk about this a bit in each one of the lanes. The leaders have a lot of things they want to know about a device. I talk about a washing machine. I talk about the fact there could be 20 different things you want to know about a washing machine. If you were to go read the standard spec for a washing machine in an IoT system, you're going to find that it's fairly narrow. It's operating, it's not operating, right? I can send an operation to start its operation. I can get a notification it's done. And actually for a standardized system, from a protocol communication standpoint, and how you manage connectivity and provide information about what your device is doing, having a tight, discrete amount of data transferred through the system in a standardized way is very helpful. When you're designing a system and you want to know 20 things, the 20th thing, right, if you think about the design of a system or a protocol, is not going to be valuable for everyone. It may be very valuable for you as a company. It's how we feel about power as related to the door systems. If we were to go in and approach any of these major players in IoT and say, hey, we're constructing a connected door system, they would say, well, that doesn't really exist in the home today. We're like, well, we know, we're launching one. Then we'd say, we want to know the power status of every periphery device, right? And whether it's operating or not operating correctly. And they'll say, we haven't written that protocol. Nobody's asked for that. So we actually had to, kind of go custom on that part of it. But, part of what you need to think about is, as you design any system, is kind of what you're willing to pay on a per unit basis, because you're going to put technology on a per unit basis onto a product. It could be a Wi-Fi chip. It could be memory. It could be a processor. And there are a lot of different approaches to it, but you have to think about, do you want a very sophisticated device? Do you want a simple device? And what you really think about the use cases and how much the use cases rely upon knowing things on the device, knowing things in the cloud, or interacting with the user. One of the most important things, and it kind of goes back to Mark's question before, is on system latency. It's a real challenge to have the ability from the internet on an inbound basis, connect to an IoT device with low latency, unless it's got power available to it, and your smartphone and the internet are all operating in fairly efficient manners. And in fact, that latency can easily exceed a couple seconds. And on average, what I've seen in my experiences can be anywhere from 3 to 6 seconds, depending on the device sophistication that you have. Being able to take an IoT device, have it heartbeat out to a cloud service, and then also be able to receive a message from a front-end application like a smartphone, and have that entire sequence diagram actually come back and deliver a result. You can stand in front of your garage door opener and look at your garage. Latency matters when garage door opener closes and you look at your app, and if you look at your app and it says open, and the garage door opener, you're standing right there, is closed, and it takes 3 or 4 or 5 seconds, your confidence in that entire system goes down as a homeowner. And in reality, the level of sophistication it takes to do that successfully is actually quite high. The investment's even higher. Lastly, you need to think about is those 20 attributes on a washing machine and how that translates into data requirements. The amount of data you pull off a device plays right back into the other considerations from a budget standpoint, from a latency standpoint, from a system investment perspective. So what's interesting is you lay out your key use cases and say, what's the most valuable use case, right? I want to deliver a custom detergent delivery system for a washing machine that people can control up and down, like the amount of scent. Well, how often do I need to communicate with my device? What kind of controls am I putting in the device? How do I provide feedback on a reporting system? How do I show an error fault, like there's no more detergent, right? When you build that system, you have to think about in that lane, how you're going to manage all of those different attributes to make sure you do that successfully every time. We move over to the connected platform data analysis side. What's super fascinating is, I've been at companies where we've generated petabytes of data at a time, thousands of terabytes a month. And with that, what actually becomes possible is the ability to be able to take that stored information and find signal out of the noise. I've been able to take distributed network systems and actually be able to see uptime percentage across the network for health, be able to actually look at usage diagnostics and use that for warranty repair data and points of failure. And that's really where the power of AI really comes out. So you've got a lot of players. IBM Watson's notable here, but Google's done a lot, Amazon's done a lot, Microsoft does a lot. There are a lot of players that can bring a lot of computational horsepower to the party. And in fact, when you start to think about this on an ecosystem basis, and you're a manufacturer of goods, like you're a door manufacturer, the reality is you're not going to have AI experts sitting in your business. But the price value of AI, as contrasted to the investment, can very quickly pay off, especially when you have the data. It's interesting, we've been asked, what is Masonite's AI strategy? As of 2 years ago, before we launched a powered and connected door system, we said we don't have one. Our doors don't have any data in them. So you have to have a data strategy first, then you can have an AI strategy second. But there's a lot of things to consider with that. And in this lane, I think one of the more important data points is the regulatory requirements that come on with the responsibility of knowing about how people use your products. So in Europe, GDPR has actually come into play with a requirement that if a user of your system comes in and requests the data, you provide it. And if a user comes in and says, I don't want you to have my data anymore, you could decouple from the device or the service and can end the service. Those are now regulatory requirements that have enveloped this entire industry and the capability of IoT devices generally. Now, the design philosophy has typically been, if you don't want a connected device and you say you don't want the service, it's a little different than saying, hey, Google, I have email, right? I don't want you to store my data. And then Google says, okay, well, now I'll be a data pass between. It's kind of hard to connect a device if you don't know who the user is in that system. So most players have said that, if you're not going to have a connected device with a system and you're not interested in having it, then it's going to operate like a standard, analog device. Next is actions and rules. And I had mentioned before this idea of being able to translate what's happening on a device, either a control or device state, and changes to that state, and being able to use that information. So there are some core fundamental techniques for translating data. MQTT is one that is a open source communicating standard. And it's very interesting to be able to take data packets from devices through the cloud and then use a processing technique like RabbitMQ that actually is a way to be able to filter a number of different data attributes per device and then look for specific required activities that could happen from that. for example, if my door opens, send me a push notification. Could be a very good example of that. IFTTT has built its cloud connections across tens, if not more than a couple hundred different partner systems, with the idea of saying, if this, then that. So I can, put a note on Facebook and have it connected to Twitter. It's a very simple social network side of it. What IFTTT started to do was say, if my car comes into a geofence, unlock my front door. If my car exits the geofence, close my garage door. So those kinds of features start to connect in an ecosystem, multiple parties, right? And if you think about latency expectations, you have the same thing here. These are laddering effect applications. What we did at Chamberlain with Amazon was connect delivery services to a connected garage opener like MyQ. The level of service expectation is very high, in the high 99% range, meaning Amazon wanted to know very confidently when that delivery driver came up to your house that they could get your door open to deliver a package securely, right? That service availability has a cost, right? And needs to be covered. And we'll talk about that here in a second. So latency is super important to your partners. Thinking about unintended device controls is also important. You don't want to have unsafe device connections by end users in an unintended way. So super interesting design philosophies there, but also making sure that you think about what kinds of things you allow users to do and not do. Lastly, then we talk about data and reporting. There's a whole bunch of different ways to think about analytics and the health of a system, as well as notification providing. Firebase is a really interesting notification server that can then take data from a sensor on an IoT device and send that to users on a regular basis. Number of platform services that do that effectively. And you start to think about like what groups get the information. That could be internal groups like, hey, when this device goes offline, tell my people in IT, right? Or tell my engineers it's offline, right? How often do you want to have that happen? What's really important in this lane is what the communication escalation plan is and how it's escalated. If your garage door opened and you wanted to know about it away from home, when would you want to know about it? How often? How fast? Right? That escalation process for a homeowner is no different than if you're in a company and you're the head of the engineering group for a company and you say, hey, like if I see a network outage, well, how much of the network? When do I want to know about it for my team? And how we're going to communicate it externally? That's a really important attribute of IoT systems when people have service life expectations. So I'm going to, for time purposes, move on and talk just a little bit about how IoT hardware and service life is created. What's interesting is users buy a piece of hardware with an expected life. Let's call a warranty period a year, 2 years, 3 years. What's interesting is your thermostat can be in your house for 20 years. Nest launches a thermostat and says, hey, we're going to sell you a $300 thermostat. And what you're really buying is a forward commitment, which could be more than a decade of digital services in conjunction with the warranty and the physical hardware. And at the beginning of the connected home movement, what happened was some companies actually said, hey, you know what, I'm going to offer a bazillion services for free after you buy my $300 hub. A company, Revolve, was a great example of this. They offered a whole bunch of connected home services with the promise that they would offer it effectively forever without really an economic model of how they were going to connect the dots between the way they were going to pay for services after they got the $300. There were a lot of people who jumped on the Revolve bandwagon expecting they would have a home hub for one app with one protocol that they could then connect all their things to. Nest really liked the team and bought the company. What Nest did that was really interesting was Nest waited past the stated warranty period and then end the life of the product, which caused a massive outcry by users, lead users of these products. When you start to think about the design of an IoT system, you have to think about the revenue you get when you are selling the hardware along with a service, component that you're providing. What's interesting is if you think about products in your life, you're starting to see more of an approach, a hybrid approach of connecting the service life to some kind of an annuity, like XM radio, like, hey, you'll get a free period, but we're going to charge you every year after that. And at least you know that that service is going to be paid for over time, and the cost is going to be borne over time, so you don't get disconnected. The beginning of the connected home really struggled with that. One of the things that's happened from a design philosophy standpoint that's super important is to think about how your hardware eventually becomes a consumable. And really, when you start to think about the design of that system and the analogies that I've drawn here in things like access controls, if you think of a lock actually really is your phone as a key, a digital access system. Well, what elements does that offer? Well, it can offer services for realtors, for people who come and clean your home, for guest management, like Airbnb. So if you think about the design philosophy of a lock and you're offering a system, what you're offering is a system that can create value over time. Then you have to think, well, how would I collect revenue from that? Great example is Nest. Nest actually connected one of the biggest energy users in your home, your HVAC system. They started working with energy providers to be able to manage your home energy with credits. Very innovative. You as a homeowner got a credit every year, and guess what? Nest got a credit every year. And they started to connect the dot between the system they were selling, which was a piece of hardware and a service, with a credit on an annualized basis. These things actually start to create the ability to fund their own services, which is where a lot of the business model innovation is. And the last point I'll kind of leave you with before we go to questions and answers is this. If you're a manufacturer of things, I'm a manufacturer at Masonite of doors. If you're a manufacturer of tires, when you think about the way to create ecosystems, not every company is $1 trillion company that has commanded the entire ecosystem. TV manufacturers actually started to see the media boxes get owned by major media companies or major technology companies, and then the media companies getting into digital services. Now, Samsung could say, well, we're going to get into delivering our own media serving device, and we're going to have our own media company. But the reality is, it's not going to compete with Disney. Disney's an amazing manufacturer of creative content. It's not going to compete with Apple. Apple makes beautiful devices. And what happened is an appreciation of how to make a product really well, which is a TV, which then can connect to hardware delivery devices. Google Chrome is an amazing device for its price, right? And Google has a reason for that. They have all their services they want to attach to it, like advertising, along with media. And those have moved a lot faster in their technology development than the actual TV itself. And a TV can be in your home for 5 to 10 years. These media delivery devices can change every 2 or 3 years. You could be a manufacturer of a TV. You could be working for Roku and think about how you add on to a TV. You could be working in a media company and how you stream to a TV. And what's interesting in this new world we live in is that we have the opportunity to think about business model innovation on how the hardware translates to services without having to own the entire stack. So Works with Nest was a great example of that. I think what most major automotive players like a BMW is starting to think about is how do they do things like partner in parking services. As we start to think about media, the Disneys of the world have a fantastic opportunity, as does Netflix, to think about being able to provide its services through the major mega techs. So with that, I know I've taken a good solid part of your hour, and I appreciate that. And I'll take any questions you have before we wrap up.
So any questions for Cory Sorice, Satu?
Yeah, sure, Cory. Thank you so much. This is my second time actually hearing you speak. I think I heard you speak in my org innovation class, which is great.
Oh, awesome. Yeah.
So I'm actually, I hear a lot of parallels between IoT and IIoT, which is what I'm familiar with. I'm actually developing my own IoT platform where I work now. And, like the biggest, kind of challenges. There's so many players right now, right? With like AWS, there's Oracle, IBM, the Googles of the world, and then the internal struggle within my own IT department, right? Which is typically your security and compliance kind of department, right? So, what have you seen, or like how do you kind of get over that kind of roadblock?
Yeah, it's interesting. One of the things that I've had to talk to boards and owners and management about is the investment and the kind of the investment requirement at a floor level to have an IoT enabled system, and kind of what that means in terms of the payoff. And that gets into, to a degree, the unit velocity of what you're delivering, how intrinsic it is to your overall business model, with a caveat, which is it's super important to be in a situation where it's really intimate to the strategy of the business overall. Because, you can say make, buy, you could look at it on a small basis and say, hey, we're going to make it, as opposed to partnering with somebody or using someone's system, which feels more expensive. But the key consideration there is what you're trying to accomplish in terms of use case adoption. In garage openers, we put it in everything we made. And it was really kind of we knew that, credentials are going to move to your phone, and you wanted to have, your phone be your digital credential. So that's really on the industrial side. I think there's a bit of a platform investment and then a price value equation you have to do.
Right.
And that, like I showed earlier, that contrasts against the amount of customization you can get for the use cases. So I think that's the interesting challenge that I think you have to look at when you approach, the IT and the management team. How have you thought about that? Is that something that
Yeah, I
you've
mean,
been able to get over the chasm on that one, or no?
Yeah, I did cross the chasm on that one. Pretty much, I think I wrapped it up into this digital transformation kind of buzzwordy thing everybody's doing now. Then, and then just try to remove technical debt, right? And kind of like typical manufacturers spend millions and billions of dollars on new equipment, and all this new equipment is IoT enabled, right?
Yeah.
And nobody ever uses it. So it seemed to be a good strategic alignment with automation and digital transformation. So
Do you feel
yeah,
like
it
the
worked.
payback's there?
Yeah.
Can you define it, and you think you can get to it?
Yeah. So I kind of started top down. Top up instead of top down, I guess. So I started with the process.
Right.
I started with people on the floor and the process people, and how I could kind of bring value to them, and then it just kind of took off. So
Kudos. It's not easy.
yeah.
I think we have another question from Georgie.
Yeah, thanks for the presentation. Actually, I have a couple of questions. One short story, like back some 10 years ago, we built a smart home showroom in the home of my partner. So we just literally automatized his brand new home to make a showroom for our product. And during that time, we installed a lock with fingerprint detection. And like past 10 years, he never used key, like ever, in past 10 years. The question is why today, after 10 years,